All right, hi there, welcome. I'm Stephen Shalita with Pluribus Networks. Thanks very much for joining us here today in the room, as well as the folks online joining us. It's exciting to be able to do this. It's been quite a few years since Pluribus has participated in Network Field Day, and our goal is to really provide the opportunity to catch everyone up. A lot of things have evolved and changed. We've recently really refocused how we're looking at our strategy from a technology perspective, our architecture. Been a lot of exciting additions to the product line, and we're looking to go through that with you here today. And if we look at the agenda from kind of a high level, we broke it up into 3 modules, and we're trying to really be able to have this flexibility to have the dialogue with you all. First module, which I will deliver, and we'll go into a technical but overview of our Netvisor operating system and our adaptive cloud fabric architecture. We'll give you a sense of what the capabilities are with that and talk about some of the use cases and where it gets deployed. Then we'll go deeper from a technical perspective. So while no doubt you'll have lots of technical questions as we go along, Alessandro Barbieri will go deeper into the technology, specifically looking at how we build the fabric, how the fabric operates, and some of the advanced services that we deliver in our fabric architecture. And then coming back, I'll provide a deeper view, actually a higher level view of what we're doing from an analytics and a performance management capability, which are capabilities that are built in the fabric. And we built this, again, to be flexible, to be able to answer questions, and also to build on today's session. So we intend to be able to come back, spend more time with each of you and with the online community to start digging deeper and deeper into our capabilities, go into demos and that kind of stuff. But the goal here is to provide, a really good primer, if you will, and a fundamental foundation of what we're doing from a technology perspective. So with that, I'll provide an overview into the Netvisor operating system, the software itself, and then the resulting adaptive cloud fabric. I'm Stephen Shalita with Pluribus Networks, and this overview is really focused on where we're taking our technology from a solution and capability perspective. Pluribus was founded 7 years ago, and originally was founded as a company that was focused on delivering kind of the convergence of storage, of compute, and of networking into a single environment. And if any of you have followed Pluribus over the years, some of the early discussions talked about hardware that brought these things together. What we built to be able to enable that hardware was a very robust virtualized operating system environment called Netvisor. And that's evolved over the years, and we've evolved from a technology perspective to be really more focused on open networking and open networking hardware, and how do we build more scalable, adaptive, fabric-based environments. And some people use the notion or terminology of SDN, software-defined networking. And in some ways, what does that mean, right? Is that software that just does networking? Is it this broader fabric architecture? So we sit in that space, but really we look at ourselves as a fabric provider from a networking perspective. We introduced our adaptive cloud fabric architecture and strategy earlier this year in the April timeframe. And really what we laid out as we introduced that is our strategy around delivering a very simple, a very dynamic, and a very secure operating environment from a networking perspective. And we'll unfold this throughout the conversation today. The goal really at an architectural technology level is simplicity. So much of networking today has become incredibly complicated. And there's no doubt in the conversation today we can get down into the weeds and everything will be complicated and technical. But the goal from a user perspective is to deliver a simple architecture, something that's plug and play, that interoperates in their existing operating environment, something that doesn't require them to change the network architecture and the way in which the network operates. The goal is to deliver a holistic network environment that allows people to support a single environment as well as scaling out and providing this cloud-like scale and elasticity within a single data center, but more importantly, to scale out into multiple data center environments. And to bring in services that traditionally have been added as add-ons and bolt-on capabilities. Some people looking at that from a terminology perspective of NFV, network function virtualization. How do we bring that capability into the network? So it's really about scale out versus scale up, which is really the new mantra in building networks today. How do we move to a much simpler architecture? So building on this, I wanted to start with kind of the framework. What differentiates Pluribus and what represents the Pluribus capability set? First, completely software-based. No hardware components are specifically required to do that. Obviously, you need a network switch to be able to operate, hence the strategy of being centered around open networking hardware. People can use the hardware that they need and want to match the capabilities. You know, hardware in many ways becomes the limiter to a certain extent. It defines your interfaces, defines the processing power and the capabilities that you have. The software is what pulls the value out of that hardware, and we're 100% software enabled. One of the key things about our architecture that we're going to spend time on today is it's a controllerless distributed environment. And this is key for you to be able to understand the differentiation of our capabilities. There is no controller in our architecture. There is no single point of control, single point of failure. While we deliver centralized management and the ability to provision and control this environment, as you would expect, we remove the obstacles and the complexities of larger scale, multi-device SDN-based fabric environments by eliminating the controller. And this allows us to scale geographically. We have no geographic limits, and many of the deployments that we have scale over many, many different locations supporting many, many nodes and many devices. It's completely standards-based. We don't use proprietary protocol. While we will support different protocols that a customer may want to deploy, and that includes, by the way, if a customer wants to build a controller-based environment because they're controlling lots of different things beyond the network, we're able to support that architecture in that environment. But our network itself doesn't need the controller and doesn't require new protocols to be introduced into the network. Everything that we've done is really built to be non-disruptive, to enable customers to gracefully migrate into next generation architectures without having to replace their existing environment. This is key for being able to support both brownfield and greenfield type deployments for that interoperability. The programmability, automation, to me is a foundation in modern networks, and we'll talk about that capability. And the other area that we believe is a very significant differentiator is we've integrated, embedded the monitoring telemetry to deliver true pervasive visibility. And the notion, a lot of people are using that term pervasive visibility that was created years ago to mean new things. We see that as a really redefining of what pervasiveness of being able to understand what's happening in the network. One of the things that we learned from our previous participation in the Tech Field Day Extra recently was how do we define and where is our product being used? What are the use cases in which we're deploying our technology? First and foremost, what we are is a data center software architecture. We sit in the leaf, in the spine, at the network. We support applications that are deployed within the data center, whether it be a single pod or a single set of applications or scaling out across a broad data center architecture. But if I break it into very specific types of use cases that people are using the fabric for in this technology, hyperconverged scale out. Being able to support hyperconverged environments, whether it's their own storage aspect of the infrastructure, or if they're using something like a Nutanix or vSAN-based or VxRail from Dell, that's a very significant part of the use cases that we're deployed in. So traditional applications scaling out into the hyperconverged environment. Things like VDI, things like big data server farms, very commonly seen, and we have a number of deployments in which they're focused originally in a Hadoop cluster and how do they deal with supporting racks and racks of processing, but then scaling out to the broader data center. Another very significant use case, and it'll make sense as we go through the architecture, is centered around segmentation and multi-tenant environments. And not just tenantization in a carrier context, but tenantization within enterprise environment, whether you're separating dev and test from production or creating a different operating environment for different business units or business entities. And that's a key part of what we've built into the architecture. Disaster recovery in being able to build active-active and scale out highly resilient environments that stretch across multiple locations, multiple physical data centers. And last but not least, we see continued growth and interest in scaling this architecture to provide aggregation capabilities into the campus and into the branch office environments. Sir.
If I understood you correctly, you said you have a software-only solution without a controller.
Correct.
So I'm guessing that what you have is a network operating system that runs on white box switches.
Correct.
Thank you.
Absolutely. And great question, because that's, I'm going to give you the picture of exactly what the OS looks like, right? So we start with a white box open networking hardware, right? And there's the broad range of what you can use within that and support. What Pluribus provides within our Netvisor software is the fundamental networking capabilities, which you think of as layer 2, layer 3 networking. And this is similar to what other open network hardware vendors do, right? And they're just providing that network function. You guys are all technical people, but for the benefit of the folks in the audience, think of this as a bare metal switch, like a bare metal server or a PC that you buy. When you buy that, you need to run something on it to make it work. When you buy a PC, you put Windows on that PC, and that gives you functionality. Netvisor provides that functionality with best-in-class layer 2, layer 3 capabilities.
To clarify, the routing stack, it's not developed by you. You are using FRR, Quagga, or someone else's, correct?
That
is correct.
Right? Yeah. So built on that is the fabric architecture. And this really is where we see the biggest utility of our product. Pluribus is not focused on selling basic OS into the market. Customers that buy our product and deploy our product are deploying it for the next set of services. So our adaptive cloud fabric, which is what we're going to drill into, is our ability, and in the next 3 slides, I'm going to break it down and show you how that looks architecturally, allows us to interconnect all of these devices together. It's where the services sit, where we do segmentation, where we do security, where we have our equivalent of ACLs, which is vFlow. All of that is built into the fabric architecture, and we're going to spend most of the time drilling into that. Sitting within the fabric is intelligence and telemetry. This is fundamentally looking at every single transaction, every TCP transaction, every flow, every connection, and allowing us to be able to report on that for performance management purposes. We also have intelligence built in, which we'll drill into, called vFlow, that understands what's happening across the network and state and shares that across all of the devices to optimize the network environment. And the last piece of our stack is, it's great to have the telemetry built in the network, but we have a full-fledged performance management platform that consumes this data, as well as other data from other network devices, to deliver performance-related metrics on application and network performance. And I want to be clear, coming from the performance management space, application from a network context, right? We're not about looking inside of the application web tier and looking at app calls. We're looking at specifically the network relationship to applications and how the network is delivering services to the actual user in the environment. So at the basic level, that's the architecture that we're delivering with our Netvisor software. It enables the adaptive cloud fabric. So I'm going to spend 2 slides on Netvisor and then come back to the adaptive cloud fabric. Everyone's familiar with the concept of VMware. That clearly is well known. Virtualize a server, take bare metal, make it into multiple containers. What Netvisor does, and many people aren't fully aware of this, is it does the exact same thing to a bare metal switch. And this is key as we start unfolding the services and capabilities that we have. We take that single white box switch and we virtualize it into multiple virtualized network devices. We call them network containers, but not to confuse everything. They're physically separated devices, and I'll drill into that at a deeper level. So when you think about that virtualization, you are running multiple switches within the switch. Separate control plane, data plane, management plane. Each one of those is instantiated independently of the other. So I can run, and again, we'll drill into this, tenant services, I can run traffic segmentation, I can do service virtualization and completely isolate it from the other components of the network and giving its own router, its own capabilities that's protected.
So this is what other vendors would call device contexts. It's not VRFs.
It's running VRFs within, and Alessandro is going to go into much more detail on this. We're running the virtualized router within this, but no one else is doing this in the context of virtualizing the switch infrastructure.
If I may, I think you're spot on. We are closer to a virtual device context from another vendor. However, this is a construct which is distributed across multiple switches, is not localized on a box. And this is what we're going to talk about later in more detail.
Okay.
Sounds interesting.
So within this, every single one of these virtualized environments is independent from the other. And in this picture, we're showing this in a single switch. As Alessandro said, we're scaling this out across the fabric architecture and able to create and move these virtualized contexts across the entire fabric environment. So the virtualization is important. So if there's questions, please.
Yeah, coming back to your remark, so does that mean that the whole fabric looks like one router?
No. And we're going to go through the details of that.
Sorry, I'll stop.
Absolutely. Yeah. It's a fully distributed network operating system which behaves like a traditional network underneath. The fabric kicks in and gives you other properties, but from a network standpoint, it behaves like a regular network.
So looking at it here, in this case, regular network, traditional architecture with the spine, with leaf, and in these pictures, the colors mean Pluribus enabled and existing network and any kind of platform that's in place. So complete interoperability. The fabric overlays on top of that, and what we use is a distributed peer-to-peer cluster technology. And what that allows us to do is to communicate across each of these devices. And again, Alessandro is going to go much deeper, but there is no controller running this. So the perception of an SDN network, the controller is your configuration point, the controller is where we're going and sending things out to the devices. If there's changes, resiliency, failures, the controller is re-educating. In our environment, everything is known and learned and state is maintained across the entire fabric itself. And the members have that knowledge and have that ability to operate without any managed controller.
So it's like Brocade's VCS fabric. They share configuration and exchange state.
They share configuration and exchange state, but we do things differently than how they've implemented that.
Of course.
Yeah. Okay? So we're able to build out this fabric in really very large scale environments. It can be dozens and dozens of physical nodes. And from a testing perspective, we've tested to certain sizes, and we have customer deployments, but the scalability is well beyond what we've been able to test so far.
So what have you tested so far?
In the 40 range,
Or
right?
moving to
45
64
range.
in the upcoming release.
Okay.
So the key about this architecture is that its ability to stretch, its ability to scale outside of a single data center. So deployment in that one data center focused on a particular pod, but more importantly, we can build this seamless fabric that scales geographically. And that's one of the biggest limitations of controllers today. How do I create a complete managed entity over multiple countries, continents, locations? And with our adaptive cloud fabric, we're able to create data center interconnect over existing network environments.
Okay, now that you opened this can of worms, how do you handle partitions?
We're going to talk about that. We absolutely will talk about that in one or two slides.
Number of questions keeps on growing up. Should we wait till Alessandro's
Yeah.
presentation?
No, well, I've got other
Yes.
pieces, but Alessandro is going to go deeper and actually go into some of the protocol aspects and the technical aspects. Okay? So because of the way that we handle the architecture in this environment, right, we can take and insert an existing networks. So if you take these two examples, the spine can stay in place. We can insert and build the fabric at the leaf level, provide and insert the security and the controls and the policy and everything that we've done while interoperating with the existing network environment. So it gives this ability to more gracefully migrate. Controller-based environments drive a bookended leaf spine type of architecture that requires you to change everything. We enable a much more graceful, staged migration strategy.
So it looks like you have to replace all the leaves in a single leaf spine.
Well, it's driven by what you want to be defined as that fabric. If you don't have to replace every leaf within that environment, you can do it based upon a cluster, leave the rest of the data center as the rest of the network, as the existing network. Or if you want to create the fabric and have the benefits of the fabric, the visibility, the control, the manageability, you would insert it across all of the leaves.
Okay.
So what typically happens from a driver perspective is some level of migration activity. Customers moving from 10 gig to 25 gig or 10 gig to 40 gig, and they're going to have to replace hardware at some point or line cards in existing switches. At that point, rather than go in and do that next upgrade on an existing chassis or the existing products, move to a white box strategy and implement the software. Not only is that going to reduce their cost, but it's also going to give them the benefits of the fabric and the managed environment.
So if I remember correctly, your synchronization protocol was done on top of TCP and completely proprietary, which means de facto, if the existing switches don't support ONI environment, I'll have partitioned data center.
No.
Do you plan to open up your synchronization protocol so it could be implemented on other devices? On other devices?
First, yes, the protocol to do the synchronization as it is with any vendor is proprietary, but it's 100% transparent. It is completely invisible to the network administrator and the user. For us to open that up to communicate to another box, I mean, that's the value of our fabric. That's the value of our solution.
Yeah.
And no one else has opened it up. If you want an open protocol, open flow, or whatever else you want to use to do that, but you don't have the same interoperability to a controller from an open flow-based system to any box or any software. So in that environment, yes, how we do the communications to be able to synchronize is what our secret sauce is, and that's the value we bring, right? But it has zero impact on the network, has zero impact on the applications, none on the users, and the administrator never touches it.
And I'm guessing that if you want to do this, you have to use some sort of overlay like VXLAN, right?
You can do it with or without VXLAN.
Okay.
Right? And again, we'll go into the architecture, but it works in the existing layer 2, layer 3 environment that you've deployed, right? Just drops in and works on top of that environment. The goal here is to not require operational changes, topology and architectural changes to the network, right? I mean, if someone's using something really old and doesn't have all the capabilities, you've got to upgrade. But the goal is to be able to simplify that environment and not require changes. The problem with many of the SDN architectures is you've got to change everything. Even within a particular vendor, if you take Cisco, for example, to move from Nexus 7K, 5K, and go to 9K or even ACI, you're changing everything. With this environment, it can drop in. You don't have to replace everything. That make sense?
To some degree. So if you deploy white box switches with different capabilities, do you understand the differences? So you can boot up your software in any environment, but the capabilities of hardware itself are different.
Absolutely.
Do you understand the difference within the distributed database?
So you can build the network out, so to be specific, what I think you're asking, and I might be moving too close to the camera, I'm sorry. So what I think you're asking is if I wanted to build a network using open switches, ONI-based white boxes, I could build different switches at different leafs. The network knows that it's a single software image that runs in the leaf and the spine and everywhere else. There are no variances. And it knows the capabilities of that box. The underlying hardware is the limiter. So if that box is only capable of giving you so much CPU power to do so much services, you may not be able to do all the functionality that a higher end box would be able to do, right? If you got a Broadwell CPU versus a Rangeley CPU, all that's driven by the underlying hardware. So you can create a completely mixed hardware environment, and our software will run on all of those boxes and provide the same functionality based upon the hardware capabilities.
Thank you.
Right? So you could use X vendor in the spine, run Pluribus in the spine. Y vendor in the leaf, run Pluribus in the leaf. And the network will function consistently. It's really the variance of the service depth, if that makes sense. How much intelligence and processing power we can deliver. When we talk about segmentation, in Ivan's question about being able to I think it was Ivan asked about the network segmentation, and doing that, some of the switches may not have the power to be able to run that capability, and other switches do. And what we've built is an architecture that can scale across those.
So as we talk about hardware, that's another question.
Yeah.
You mentioned physical separation. A lot of low-end switches give you single buffer, give you single way of operating. So they don't really support physical separation. How do you deal with chatting neighbors, with, you are doing multi-tenancy on single device. How do you really provide physical separation between different tenants on a device?
So I'll let Alessandro answer that.
Yeah,
because he's familiar with the hardware.
I do have a section specifically on this, if you don't mind, because this is actually a deep question. We're going to take into my section, where we talk about segmentation.
Thank you.
So I think we've covered a lot on the hardware, but again, the strategy, open networking, white boxes. At a software level, Pluribus delivers the software. Customer can buy it perpetual, they can buy it subscription, whatever they want. We do have hardware, as customers do ask for bundled hardware software solutions. They want a turnkey environment. And we provide that hardware and support that hardware to our customers if they want that. Or they can go and source the hardware from a various number of vendors to do that. But in that environment, yes.
For people that were familiar with Pluribus from the past, where it was a kind of a unique piece of hardware that was a server with a switch built in, is it something like that you're still selling, or is it just more of a traditional white box?
It is a standard ODM white box that we take that capability with the Broadcom CPU, with a Rangeley or a Broadwell, I said Broadcom CPU, Broadcom switch silicon, a CPU, basic configuration, and provide that with a turnkey service offering. The earlier product, the E-Series, was that evolution of the server switch strategy that Pluribus was originally founded under. And there are customers that are still using those switches. We call that the E-Series switches, but our F-Series switches are just basic white box technology. And the way that we've built them is they are ONI-based white boxes. They don't have to run Pluribus software, so a customer could buy them and use them with another operating system and have consistency within their network environment at a hardware level. With one particular product as an example, what we call our 9532C, I can build an entire data center with one box. I can do 10 gig, 25, 40, 100 gig, put that same box everywhere and have a single SKU. And the value of that is operational simplification, sparing simplification, lots of flexibility. You can do that with a standard white box from white box vendors as well. So what you're able to build, and this is really building on the point that I mentioned, is a single network environment, in this case 100 gig sitting in the core, running 10 gig, could be 25, 40 gig, because it's a multi-PHY, multi-speed network switch, but build out this entire network leveraging a single physical device and building this in a structured way so we can segment the network, so we can control the network, leveraging the Netvisor operating system and the adaptive cloud fabric. So a lot of flexibility to build out the architecture to meet the deployment requirements.
I may have missed it, but with end touch points in the network, how do you manage I guess a Pluribus fabric? Is it box by box, or how do you?
Oh no, it's completely, and we're going to go into that. It's completely automated with a single management point, and that's the key. The hardest thing I think in all the conversations I've had is to get the understanding of this architecture and it being a controllerless environment. And okay, so how do you manage it? We've been able to build an environment that functions like a controller-based environment with a single point of management and configuration without a controller. And we've given the flexibility to be able to manage that from any device in the network with no single point that's consistently in control, right? To build that out.
Cool.
So security policy built into the network and scales across. And again, as Alessandro drills in and talks about objects and goes into the protocols and the capability at the architectural level, we'll be able to pull these pieces together. But as we build this data center stretch data center environment, data center interconnect-based environment, running over any network, we're able to create consistent policy distribution across that environment, right? There is no single point of control, and we're going to go now into how we actually do the segmentation, how we're able to implement the security piece into this. And I want to talk a little bit about intelligence, because Alessandro is going to drill deeper into that. We have a technology within our fabric that's called vPorts. vPorts understands the endpoints that are connected to the network itself. And what it does is it learns that data, it understands that endpoint mobility, that endpoint state, and changes. So for example, you have a server sitting in data center A in Atlanta, and that workload moves to data center B. The vPort technology understands that, learns that, and distributes that to all of the other member devices. At the first level, it eliminates and reduces learning, right? Flood-based learning across the network environment. But that also adds to, again, go deeper into the visibility capabilities and intelligence. And this extends into VMware. It's VMware aware and vSphere aware, so it understands the constructs of what it's physically connecting into, right? So we'll continue to build on this. Second is the resiliency optimization capabilities. And the way to think of this fabric environment is it's chassis class resiliency, right? You all know how a chassis works. I take that supervisor, I got line cards, supervisor's redundant, fails over. Well, we don't have a supervisor. We didn't take it and put it into a box. The network's completely distributed. And resiliency is sub-second failover anywhere across the network because there is no reconvergence. As you'll learn, everything is learned and understood in the individual member switches within the operating system. There is no point feeding and telling these different switches what their behavior should be, what the policies are. Once they're known, they're immediately shared across the fabric in seconds, learned and remembered.
You mentioned earlier, though, like a total amount of switches that could be in a fabric. Was that 48 or 64?
Tested. Today tested 40s
Okay.
and deployed. 60s
So if I had like
in the
a
next
huge
release.
data center, I could have like 2 fabrics.
You could build 2 fabrics,
Okay, understood.
and then within our management environment, you can manage the fabrics side by side.
And then just L3 between them.
Right.
Who cares?
But even if you're going to build out a large data center, do you really want one super
Well,
fabric,
yeah,
or do you want to break?
Yeah, understood. Just
Right.
kinda-
What you lose between 2 separate fabrics is the cross segmentation, the cross virtualization, and the cross mobility.
Right. Okay.
Just to be sure, in most of your diagrams, you had your switches as leaf nodes. I
That's
guess.
the typical deployment.
Okay.
So we can deploy anywhere within the network, and if you imagine everything we're talking about, that's where your policy, your segmentation, everything is being applied. So if I'm putting it at the spine, I'm not getting the segmentation down at the application level because I'm not touching the application traffic, right? I'm aggregating it. So it just depends upon where you're deploying it. Most customers in the deployments we've seen, they say, you know, I've already got this huge investment in 7Ks or whatever that's sitting in my core. I'll go in and insert this into the top of rack.
So you're talking about segmenting at the application level at the leaf switches, but what about going into the hypervisor where switching is happening within the server hypervisor?
So what we would be able to do, and we'll go a little bit into that today, within the micro-segmentation that's going to take place within the hypervisor environment, because you're running the vSwitch within there and doing segmentation, right? We're not at the point of full integration into the vSwitch environment to be able to make it a seamless. It's not like the 1000V where they built that complete connectivity through there. But at the application, I actually use this picture, at the application level, what we're able to do through this virtualization, and Alessandro is going to go much, much deeper in the pieces of this, is to create the virtualization of those different VMs and create, the colors represent different tenants or different service segmentation, right? Macro segmentation, whatever you want to call it. I can do it for traffic flow. I can do it at a tenant level. I can do it for specific application separation, DevOps, production separation, and I actually build those different network components at a virtualized level.
Sure.
And it lives across multiple switch devices. It lives across multiple locations. So if I take one customer example that will illustrate this, there was a customer that has 3 data centers, 2 in the US, 1 in Europe. And they wanted to create a data center interconnect between those 3 environments for resiliency and control, for management. And they were able to build this one fabric across these 3 geographically spread data centers. But then they came back and said, we have 8 different operating companies and we want to completely isolate the traffic between those. Oh, and by the way, we don't want to use VLANs. How do you do that? We're able to build that separation across those 3 data centers into 7 virtualized networks that live in 3 different locations without using VLANs through this segmentation. So complete isolation of the control plane and the data plane. If you are running a tenant environment in which 4,000 VLAN availability, space availability to your clients is important, if you're a large hoster or provider, you're able to do that and preserve the number of VLANs and not have to do VLAN mapping.
I have to ask this question because you had that on the slide. If each tenant has full 4K VLAN IDs, and I'm running on a regular switching silicon that only supports 4K VLANs per box, how does this match?
That's what the virtualization does. The virtualization has created multiple switches on that box.
Yeah, so at the data plane level, we map those VLANs on different VNIs. So
Yeah, but still, there's only 4,000 VLANs per Broadcom chip.
yes, up to 4,000 per cluster, but then you take another cluster. And
Okay,
you have
that's a different story.
and
Yeah.
then you map them to different VNIs underneath. Yeah.
Okay? So from a management perspective, and you know, we're being very aware of time and kind of building this as a process to reintroduce everything. I'm not going to go deep into the management and demos in today's session, but manageability within this environment is what you expect from a software-defined platform. CLI, API, and complete parity between both choices. So regardless of how the customer wants to manage the environment, they don't have to give up functionality and choose, okay, everything's API or less functional if I use API versus CLI. We also have our own management platform called Pluribus UNUM, which again will be a deeper dive section. I'll talk a little bit more about it with context of analytics, because we've integrated the analytics, the management, and other things into this single platform. I just want to give you a preview of that. But being able to manage this environment and manage the physical virtualized tenants and segments that we've talked about is all controlled here, and each one is independently managed. So if I build that tenant environment, and I'm doing tenants as opposed to traffic segmentation, I can manage tenant A with CLI, I can manage tenant B, API-based, I can use Ansible for tenant 3, and I can use the Pluribus management platform, Pluribus Unum, for tenant 4, just to illustrate the diversity within the environment.
Does your platform expose some APIs northbound of it? Can I plug it into another management system?
Yes, yes. So we've done and have customers using homegrown, using Ansible environments, and being able to plug it into any other environment. That's the key. That's the starting point of the technology. The command line itself is very powerful. Even the analytics that I've mentioned several times, I can pull all the metadata and all the analytics information from that command line. Everything that we've built has been built on top of it to make it easier, right? And it is completely API powered.
So how much of this is available on a per tenant basis? Okay, you want to delegate to the tenants. You mentioned the...
Everything.
Okay.
So I can say, your tenant, or if I'm using a managed service environment and I want to give the tenant control of their environment, I can parse all of the controls and visibility and telemetry specifically for that tenant, because we are physically virtualizing these different operating environments. It's not this VLAN-based overlay. It's separated networks.
So what does the tenant see when they get a fourth of a box?
They see their ports as if it were a box.
Okay.
Or their ports across multiple boxes.
And so if I'm in the third quadrant, if you will, of this box, do I start with G0 or Ethernet 0, or is it?
Alessandro, it starts, each one of the tenants starts as a base Ethernet 0, as a base configuration, right?
If it's I don't know, if it's a block of 16 ports, does it always look like just a 16-port switch?
No.
Okay.
We'll go through that
Okay.
later on, right?
All right.
It is slightly different, but
Okay. We'll get there.
So
yes.
mention Unum. the management platform, because that brings us to when I talk about the analytics. And this is relatively new capability. If you followed the company, there was a product, VCF Center, that did that, but this really has come a long way. It's providing the device and fabric management, provisioning automation across the entire fabric, as well as topology visualization. And the key to that is, I talked about the adjacencies. We can see all of and manage all of the Pluribus-based fabrics, but we can also see adjacencies of other vendor switches that are connected to the Pluribus switches. So when you have a leaf spine environment, if the spine is a Cisco or a Brocade box, you're able to see the connectivity between that. The second thing that we've done is we've integrated the analytics capability into the platform. And this is key. Not bringing this up in the spirit of, we'll talk about it more in a future discussion, this is how you bring together and get to intent-based networking. By bringing in analytics and you bring management all into the same environment is how you're going to be able to automatically understand network state, understand network performance, be able to define intended state and performance, and adjust the network automatically, because it's all built in. Of all of the different intelligence pieces of telemetry, we start to bring that together, and this really gets you to the point of doing that. Not intending to go deep into that today, but it really is a key part of why we brought all this together into a single platform environment. The other thing we've done from a management perspective, realizing customer network environments, is deep integration into the VMware environment. So complete provisioning from vCenter. Some areas, nothing special there. Other people have done that. In other areas, because of the visibility, because of the vPort integration, some of the things that we're doing around the vSAN automation, automate, bless you, bless you, all of the multicast vSAN environment, bless you, troisième fois, is key. So being able to orchestrate from one point so the virtualization administrator can control and move workloads and reconfigure the network with a single button push really is an important aspect. And to the question you asked in tenants, you have complete control over what that virtualization administrator can and can't do, and if there's an approval process from when they request that. But the key here is to really accelerate provisioning and accelerate operation. So when you go in and a virtualization guy wants to create a vMotion, and then you have to go ask the network guy, you don't want it to be vWait, you want it to move. And they're able to actually push that button, bring it across the network. And this extends into NSX in being able to provision for the NSX environment. So
sorry, when you mentioned NSX.
Yes, that's okay.
If I would be running NSX, is then your fabric just a transport IP
Correct.
transport fabric for
VTAP,
NSX?
terminate the VTAP, terminating the NSX, but then we would be able to orchestrate the provisioning of the network environment. And there's a number of things we provide, which I'll talk about in the next section: visibility into the tunnel, right, and seeing what's going on in NSX traffic, which a lot of the performance management guys can't do.
True.
As well as the optimization of the tunnel, of the VTAP itself, right? Multicast for vSAN running out or in that environment as well.
True.
Okay? So again, recapping what we believe and what we see as the significant differentiators, and it's perhaps the most challenging of our architecture to get one's head around is the controllerless environment. And that really is a very, very significant differentiator. The second major differentiator is the virtualization of the hardware and of the software itself, so that we're able to very effectively apply these services and capabilities. And now we go into a much deeper view of how we actually are doing that at a construct level. Right? The performance management capabilities are also a significant differentiator, and I'll touch on those in the third section of today's environment.